everyone. I'm going to show you how to derive the law of cosines. Much like the law of sines, the law of cosines is a formula. It's a way for us to find out missing information out about any triangle, so not just right triangles. The law of sines was a formula that related the side lengths to the angle measures that were across from those sides. Here, the law of cosines is going to be a formula that relates the lengths of all three sides to the measure of just one of the angles. So we're going to start off again by thinking about just an arbitrary triangle, ABC. Maybe it's a right triangle, maybe it's not. But to ensure that we have right triangles to work with, we are going to draw in the altitude from A across to side BC. So drawing that in, that gives us a right angle, and now we have two right triangles to work with, one on either side. Just so we have some things to reference here, let's label that as H for altitude, and then the side lengths across from the angles, I'll say this is A, this would be B, and then over here this would be lowercase c. So the first thing, this is the law of cosines. So let's start by doing the cosine of angle C. Now the cosine is the ratio of the adjacent side to the hypotenuse of the triangle. So I'm just looking at this small right triangle here. I know the hypotenuse is B, but my adjacent side is this length right here. I know the entire length of BC is A, but I don't know how long this piece is. So I'm actually going to introduce another variable here, and I'm going to call this x. So that means that the cosine of C is equal to x over b. Okay. Earlier I said that the law of cosines related the side lengths to the measure of one of the angles. Well, here's the one angle we're going to use. So now I need to get all three side lengths involved. So the other tools I have that I can use with right triangles, at least one that works really well with side lengths, is the Pythagorean theorem. So I have two right triangles, and I'm going to use the Pythagorean theorem twice. For this triangle on the left-hand side, the Pythagorean theorem is going to look like x squared plus h squared, and the hypotenuse squared is b squared. For the triangle on the right, I know two of the sides, h and c, but I am missing that other leg of this triangle. So again, I know the entire length is A, but I just want this piece here. So if the entire thing is A, I already called this part x. From this altitude to B, this is going to be the leftovers, or A minus x. So then in the Pythagorean theorem, that is going to look like A minus x squared. For one of the legs, our other leg is plus h squared, and that is equal to our hypotenuse, which is c squared. Okay, so I have these three formulas here. I am going to combine these together in such a way that I can eliminate the h's and I can eliminate the x's. Both the x and the h were things that weren't a part of our triangle originally, so I want to eliminate those, so I'm only using the information I know about the triangle to start with. So to start, let's take this binomial here and we'll multiply this out. That's going to be a squared. In the middle, it's a negative a times x, and then another one of those, so minus 2ax. and then x squared, and then we have the rest. So if I look at this equation, I got an x, I got an x squared, I got an h squared. I want to get rid of all of those things. And we're going to use these other two equations and some clever substitution to help us do that. So this first one here, we do a little bit of rearranging. We'll multiply both sides by b. That gives me x is equal to b times the cosine of c. So now I know what x is, so I can replace this one here. So a squared, 2a, and now we'll plug in this entire expression. So b times the cosine of c. And then our other two, so x squared and h squared, this entire piece here, that is the same as that. So those two added together is the same as b squared. So plus b squared is equal to c squared. So two nice pieces of substitution, and we don't have x's or h's anymore. And now let me just do a little bit of rearranging. So I'm going to switch the order here. So I'm going to do c squared is equal to a squared plus b squared. So far this looks like the Pythagorean theorem, but we do have a little bit of extra here. So minus 2ab times the cosine of c. So this little bit of extra that we are subtracting at the end, this is what helps us take into account the fact that maybe this isn't a right triangle. But here, this is your law of cosines. We ended up with it this way because of how I labeled the triangle to start with. If I choose a different angle for my cosine here, I can end up with similar formulas. I can end up with one that's b squared is equal to a squared plus c squared minus 2ac times the cosine of b. And the last option, a squared is equal to b squared plus c squared minus 2bc cosine of a. And those are the three possibilities for the law of cosines. So it is important here to note that you don't need all three. They're just listing off the different possibilities. But if you look at the way the variables are, here's side length c. That matches up with angle c. Side length b, angle b. Side length a, angle a. So when deciding how you want to fill in your equation and do your substitution, the angle that you are given, or the angle that you want to find, the side that is across that from that, that is the side that needs to be all by itself on one side of the equal sign. So if we look at our picture here, that one with this first equation, here's angle C. This was the angle I decided to use. Across on the other side of the triangle is side length C. So that's the one that's all by itself. Based on that, and kind of the layout of our information here, we kind of have two situations on when we can use the law of cosines. So the first one, we can use the law of cosines when we know two sides and the included angle. So this would be side angle side. So if I knew side AC, and then I knew the angle in the middle, and then I knew side BC, I could use the law of cosines to figure out the side opposite there. And the second situation, and when we can use the law of cosines, is when we know all three sides. And this is the side, side, side case. And if you know all three sides, you can use the law of cosines to find the measure of one of the angles.